Alright, hello everyone and welcome to Lab 8. This is the final lab for the fall 2020 semester, and this week we're covering the synthesis of diphenylacetylene. So the purpose of this experiment is to synthesize diphenylacetylene, which is this molecule here, using a reaction called a double dehydrohalogenation, and specifically we're performing this reaction on the 1,2-dibromo 1,2-diphenylethane that we synthesized last week. So this is essentially a two-step synthesis, and we're on our second step this week. So the first thing to cover in this experiment is I want to cover the double dehydrohalogenation experiment. So double dehydrohalogenation. So in a generic sense, this reaction consists of some sort of dihalide, so where X equals a leaving group, so X equals a leaving group, and you convert this molecule into a triple bond. And this leaving group is typically bromine or chlorine or some sort of halogen. And this reaction proceeds well in the presence of heat, so you need to heat this reaction. Sometimes the heat is represented by the Greek letter delta. And the other thing about this reaction is it consists of two consecutive E2 reactions, so two consecutive elimination reactions. Oh, and I mentioned you need to have a base as well, a very strong base, and typically two equivalents is necessary. So since you're performing two consecutive E2 reactions, you need to have two equivalents of base. Now, the other thing I wanted to mention is the nature of the dihalide. So when you have a dihalide, dihalide that looks like this is referred to as a vicinal dihalide, or a vicinal relationship, and you can see that the spacing between these two halogens is 2 carbons, so there's a 1-2 relationship between them. Okay, they're within the same vicinity. That's sort of how I remember it. And the other possibility for this reaction that you need is if you had a geminal relationship. So geminal comes from the word Gemini, meaning twin. So these halogens are sort of on the same carbon, they're twins of each other. So both of these scenarios will work for a double dehydrohalogenation experiment. What will not work is if you have this sort of relationship. So if you have a 1-3 relationship, this will not work for double dehydrohalogenation, DDH. So now that we've covered that, let's look at this specific reaction in the context of our experiment here. So we have our 1,2-dibromo 1,2-diphenylethane, and it's going to be reacted with sodium hydroxide, that's our base, and in a solvent of diethylene glycol. And it will synthesize our diphenylacetylene. So specifically, these two bromides are not geminal, they're vicinal. They have a 1-2 relationship. So let's examine how the mechanism works, and the mechanism is very straightforward. So we have our starting material. Okay, there, and then I'll add the bromines. Okay, but also on these carbons are hydrogens. So there's an H here, there's an H here, and it doesn't really matter which hydrogen is abstracted first. So we have hydroxide from the sodium hydroxide is a very strong base. It's going to pick up the hydrogen. This bond will become a double bond in the center, and then this bromine will leave. Okay, so this is the first E2 reaction that takes place. Okay, so we still have a bromine here, and we still have a hydrogen here, and then the second equivalent of hydroxide will deprotonate this hydrogen, and then this bond will become a triple bond here, and then the bromine will leave. Okay, and this will generate our diphenylacetylene product. It's now a triple bond. So we've gone from an alkane to an alkene, and then finally to an alkyne. And then just to be thorough, this will generate basically 2 equivalents of water, and also 2 equivalents of sodium bromide. So these are the byproducts of the reaction. Okay, and the final thing I wanted to mention about this specific reaction is that heat is necessary. So this molecule, the diethylene glycol, this boiling point is very high. I believe it's around 245 degrees Celsius. But for the reaction, we're only heating it to 160 to 170 degrees Celsius. So these reactions occur very well in the presence of heat. So by heating it to such a high temperature, it's almost twice the boiling point of water, we can make sure this reaction occurs in a very short period of time. So thanks for watching, and we'll see you in the experimental. Alright, welcome to the experimental of the double dehydrohalogenation experiment. So here's our reaction vessel. It's very simple for this lab. It's a glass tube with 1 gram of our 1,2-dibromo, 1,2-diphenyl ethane. So this is the product from the last experiment. There's 1 gram of it in here. And the other reagent we need is some sodium hydroxide. So this is about 6 or 7 pellets of sodium hydroxide. And it's important that we try to get it in there. This substance absorbs water very quickly from the air. Very important that we try to get it into the vessel as quickly. See, it was already absorbing water. Okay, so now we have our reagents combined in our test tube, and now we need to add our solvent, which is diethylene glycol. It's a very viscous liquid. So we have 4 milliliters here, and this is the solvent for this experiment. Okay, so we've added our solvent, we've added our base, and we have all our reagents necessary. Now, the heat for this reaction is supplied via a sand bath, and that's because the temperatures required for this reaction are very high. So when you have a double dehydrohalogenation, you need to have very high temperatures to get the reaction to go. And this sand bath will supply the heat. So a sand bath is very good at retaining heat, so there's a lot of thermal mass in the sand, which we will submerge this test tube into. To monitor the temperature, we have this apparatus here. So this is a thermometer that goes up to 200 C, and it's sitting in a smaller test tube with a little bit of diethylene glycol here, and this will sit inside the test tube and measure the temperature. The reason we add the extra test tube is to give it a bit more strength, because we're going to be using this as a de facto stir bar to agitate the solution while it reacts. So here's the tricky part. We have to slide the thermometer into the tube without it coming loose. Okay, there we go, and now we can put it into the reaction. Now the goal here is to keep the temperature of the solution between 160 and 170 degrees Celsius for at least 5 minutes. So that looks good. Clamp it in place here. Make sure this test tube is hitting the bottom. Okay. And now we're going to agitate for 5 minutes. Okay, so we've been heating it, and we've just about approached 160 degrees Celsius in the thermometer. But if you'll notice, maybe you can see if I move some of the sand, that the solution here is actually beginning to boil. So this is a new sand bath we have, and it's very good at heating. So we've never seen heating this good in our experiment before. And you can see that the solution's actually boiling. It's that hot. So I'd say we're at about 160. Yeah, there we go. And we've even passed it, 160 to 170. So the goal now is to keep it at that temperature for a duration of 5 minutes, and that should be sufficient to ensure the reaction goes to completion. So we'll continue to stir for 5 minutes, and then we'll take it off the heat and we'll work it up from there. Okay, so we've completed our 5 minutes of reaction. So what we're going to do is we'll raise our test tube out of the sand bath. So we've stopped applying heat. And our product should be in solution here. You can see it's still kind of boiling there. The goal now is to isolate the product by precipitating it with some water. The problem with that is if we add water to it right now, we could crack the flask. So this vessel is at very high temperature. So we're gonna have to let it cool to room temperature for a little bit. Then we'll add some water, which should precipitate the product, and then we can recrystallize it from there. All right, so we've got a pair of tweezers, and we're just going to carefully extract this. Okay, so if you'll notice here, looks like there's some sticky residue So we're going to try to wash this. We're going to add some water to this flask to precipitate the product, but what we'll do is we'll also try to wash the inner tube here. So I got some water. Okay. Then we'll add 10 milliliters of water. Okay, we'll also set this aside. And we'll just use a thermometer. I'll be careful here. Try to stir this up. So we have a very viscous goo here, but you can see the product precipitating. It's a white solid. Okay, let me add a little more water. It seems like there's a lot of goo. If we add extra water, it shouldn't matter. The product isn't soluble in water, so using it to dissolve the solvent. So the ethylene glycol is very polar. It's got 2 OH groups in it. Sorry, diethylene glycol is very polar. And it should be removed in this water here. So let's just agitate this a little more. Add more. The amount we add here is not very critical. Yeah, it looks like we might lose some of it on the sides here. Okay, so I think that's sufficient. Now what we're going to do is we're going to filter this, so isolate the solid. And over here we have our filtration apparatus. Okay, sorry, we had a camera issue here, but we've set it up, so we've got our vacuum filter. So let's turn on the vacuum and dump in the crystals. So turn that on. Try to agitate this. So I'll add a bit more water to try to rinse out this residue in here. So it's reasonably dry now. So this isn't the final filtration. This still has to be filtered. So you can see some off-white crystals there. So the product should be a white solid. This one has some color in it, indicating that we have some impurities. So what I'm going to do is I'll take this filter paper, or sorry, this weighing paper here, and we'll scrape out the crystals. So just dab that water off. We got our spatula here. So right now it's a very pasty solid because it has a lot of water in it. Okay, so we've got our crude crystals of diphenylacetylene here, our product, and I'm going to transfer them to this test tube, and this test tube is what we're going to use to recrystallize it. So instead of doing it in a beaker, we'll do it in a test tube. It'd be kind of convenient if it would cooperate. So the crystals are still fairly wet, so it's making it a little difficult to transfer. Alright, so we've got our solid inside the test tube ready to go, and I'm going to get some ethanol here to dissolve it. So we'll start with about 2 milliliters, so let's try to rinse down solid here. Okay, a little bit more. So I'd say that's about 3 or 4 mils. And what we'll do is we'll take this and put it back into the sand bath to gently heat it until it dissolves, and once it dissolves we can let it cool slowly and we should form some nice crystals. Alright, so we've been boiling our mixture here. So we have about 3 milliliters, I would say, of ethanol in here, which is a solvent for the recrystallization. And what we'll do is we'll put it pretty much directly into an ice bath. Now typically when you do a recrystallization, like in our acid analyte synthesis, you want the solution to cool very slowly. But when you're dealing with small amounts like this, they don't like to crystallize very easily. So by putting it directly into a cold ice bath, it helps. So we'll also add a little bit of water just to help it. So you can see it crashed some out. So those will help seed the reaction. So we'll place the glass, the test tube, into the beaker and we'll let it cool for maybe 5 or 10 minutes. Okay, so we've got our crystals here in our test tube. They've been chilling for a few minutes. So what I'm going to do is I'm going to agitate the solution real quick. let me add a little bit of ethanol to it to help break it up. So this is cold ethanol. There we go. Okay, and now we can turn on the filter and filter it away. Okay, you can see it, but it's a fairly white crystal here. Okay, so you can see we have a nice white powder inside the funnel, and that should be our fairly pure product. So the blue object is a stir bar that I use to heat it. And there's still a little bit on the filter paper, so I'll try to scrape some of that off. Okay. So now we'll take our powder here and we'll place it into our sample vial, which is pre-weighed. Okay. So we'll place this vial into the vacuum desiccator and let it dry to remove any residual water, and then we'll get a final mass. Okay, see you then. So we've got our product here. It's a white solid, and it's been in the vacuum desiccator for about an hour. So now we'll place it on our balance to get a yield. So it looks like we have 13.15 minus 13.11. So it looks like we have 0.04 grams.